Hi, let's spend a few moments together to better familiarize ourselves with the OverOps Reliability Analysis dashboard. This dashboard enables folks in a dev capacity to understand exactly which potential critical errors, anomalies, or slowdowns are taking place within their environment as they look to release code or verify the overall health, reliability, and quality of their applications. This dashboard is comprised out of four critical parts, each highlighting a different group of anomalies within the environment. To the top left, we have the new errors view. To the right of it, we have all errors within this environment sorted by their rank. To the bottom of that, we have increasing errors, ones that have regressed. And last but far from least is slowdowns. Any transactions there are essentially slowing down or showing abnormal performance in terms of the ability to respond quickly. Let's begin going one by one and understanding really the value that each one of these panes provides us with. The new errors dashboard shows us a prioritized list of all the new errors that were introduced within the currently observed time frame. These errors are ranked by severity as either P1s or P2s. A P1 error is an error that has been introduced within the last, in this case, 24 hours, is either uncaught, which means it is not handled by our code at all, which most likely will have very unpredictable results. It is of a critical exception type, such as a null pointer exception, a class cast exception, assertion errors that should never really happen within any code that's a candidate for promotion. Or last, are errors that are new to this time frame and their volume has exceeded the target threshold. For example, we may introduce a new logged error that has happened 1,000 times over the last 24 hours. That is also something that would merit inspection. So for each one of these errors, I can hover over and see exactly why this error is perceived to be either a P1 or a P2. Hovering over the name of the exception, I can see exactly its type, where it's coming from, the code, the transaction in which it took place, and what release it was introduced by. Clicking each one of these errors will take me to the OverOps root cause analysis screen, which will provide me with the complete source code and variable state, debug level log statements, the state of the JVM at that point in time. So as a developer, it's very easy for me to go ahead and be able to reproduce and address the issue. If a JIRA ticket has been assigned for this specific error, I can hop and jump into it directly from here. To the right of this pane, we have all the errors happening within this system, but sadly, these enterprise environments can have hundreds if not thousands different locations encountering errors. It is critical that we rank them, and that's exactly what OverOps does. It ranks errors by severity. The severity is influenced by how unpredictable would the results of this specific error and exception be on the application. So uncaught exceptions, for example, are marked as high priority, followed by critical exception types, things like such as null pointers, class casts, again, things that should never make their way into a high-level environment or be released to customers and into production. And then followed by HTTP errors, which mark failure of a specific transaction to produce, and from that point on, log errors, warnings, SWOT exceptions, and caught exceptions. Within each one of these groups, sorting is done by first highlighting new errors, following by those that have regressed in terms of how often they're happening. Something that is happening more will be prioritized, will be pushed up the list, and then by everything, by essentially the absolute volume that an exception has. So something that's happening more will have a higher ranking. So with this auto ranking, essentially, OverOps is telling us these are the important errors within the environment. This caught null pointer exception, this caught index out of bound, this uncaught error. These are the things that you should be taking a good look at first. And of course, by clicking each one of these, I can jump in directly into the root cause analysis screen and be able to reproduce and address the issue. Below that, OverOps, we can see the increasing errors pane, which uses machine learning to identify for each distinct error whether or not, even for errors that have existed before the observed time period, they were introduced last week, last month, or last year, whether or not any of them are behaving erratically, have increased, have regressed. And again, assigning priorities, something that's just mildly regressing will be a P2 versus something that's happening more than 100% compared, more than double than what it used to, will be highlighted as a P1 severity. Again, all these thresholds are configurable through the OverOps settings dashboard. And I can very easily click in here and see exactly the behavior of this error. I can see in the right here, on the right-hand side, I have the dashed line, which shows me the active time frame, the last 24 hours, compared to everything that happened before. And I can see how the ML is picking up on the spike, both in terms of percentage points and in absolute terms, and also showing me any regression, any deployments that happened during that time. So I can correlate potentially was maybe this release 2240, which caused this regression to happen. And of course, clicking this error from here will take me to the OverOps root cause analysis screen, so I can see no longer not just that this thing is happening, but also what is causing it. And then last but far from least, we have the slowdowns pane, which observes the performance of all transactions within my environment and makes a call on whether or not a transaction is behaving normally or is slowing down or has slowed down. A transaction is defined as any code that's receiving an incoming request from the JVM or from the container from a new thread. OverOps automatically detects that, so that could be a servlet, an actor, a Java 8 feature. Everything is automatically detected by OverOps as it analyzes the code. Then each one of these transactions, a baseline is automatically created for that, and any diversions from that baseline are highlighted. I can see exactly why the system is giving me a warning with respect to each and one of these transactions. I can see I don't have any P1s, and of course, clicking any of these will take me to a breakdown screen, which will show me the complete state as to why this transaction is slowing down. So I can see the spikes in performance here as compared to the average. Again, having the ability to compare the baseline, showing essentially the baseline period to the left of the red line and anything to the right. I can see the average and the baseline. I can see the difference is not that big, but still the system is detecting it and it's providing me with a warning. Should this further increase, should this slowdown further increase, the system will automatically escalate this to a full-blown slowdown. So with these 4 views that I have here, it is very easy for me as a developer to be able to see what's going on within my environment, and even within a massive environment to be able to slice and dice, which really also is true when it comes to the ability to use the selectors here to focus on a specific microservice, app, group of applications, a specific server group if I'm testing a new release on a specific group of servers in a canary situation, focus on a specific deployment, only show me data from that deployment, only data from a certain group of transactions such as servlets, message processing, top 3 erroring transactions, slowing transaction, I have very powerful macros, or just search for any specific error that that is of interest here. And of course, these nice tooltips here on the bottom, on the top, show me everything that I need to know with respect to transaction failures, and of course, the overall score that is assigned to this environment or to this application over the last 24 hours. Enabled me as a developer to really focus, even in a massive enterprise environment, on those specific errors, issues, and slowdowns using OverOps' ML and AIOps capabilities.